February 20th, 1943, north of Kasserine Pass, Tunisia. German tank commanders stared in disbelief. 5 American Sherman tanks were moving through dust and chaos, across broken ground, out of sight of each other. Yet somehow, they moved as one. Each tank covered another's blind spots. Each turned and fired in perfect synchronization. No flags, no flares, no messengers. To German crews, it looked supernatural. Inside their Panzer IVs, commanders shouted into radios overwhelmed by static. Their 10-watt Fug 5 transmitters, cutting edge in the 1930s, barely reached a few hundred meters when the tanks were moving. But the Americans were using something new. Every Sherman tank carried a 25-watt, crystal-controlled FM radio capable of cutting through engine noise and static like a knife through paper. What the Germans witnessed that day wasn't luck. It was the moment the most decisive technological advantage of World War II revealed itself. Not in armor, not in guns, but in the invisible spectrum of radio waves.
It started quietly on July 22, 1941. The U.S. Army standardized 3 radio systems: SCR 508, SCR 528, and SCR 538, built by a small company in Chicago called the Galvin Manufacturing Corporation. You know them today as Motorola. Their engineers, Daniel E. Noble and Henryk Magnuski, were developing something the world hadn't seen before: frequency modulation, or FM, designed for the chaos of combat. Their creation weighed 181 pounds and transformed every Sherman tank into part of a connected battlefield network. The SCR 508's BC604 transmitter pumped out 25 watts of power, 2.5 times stronger than the German Fug 5. It used 10 preset crystal-controlled channels, immune to the frequency drift that crippled older radios. But the real revolution wasn't power, it was clarity. Edwin Armstrong's FM technology eliminated the static that plagued amplitude modulation. When a German radio heard nothing but interference, an American crew heard clear voices.
November 8th, 1942. Operation Torch. American armor landed in North Africa, equipped with the new SCR 508. The Africa Corps, experienced, confident, and armed with excellent tanks, had no idea what was coming. German doctrine relied on strict radio hierarchies. In a platoon of 5 tanks, only 1 or 2 could transmit. The rest could only listen. When a command tank was destroyed, easily identified by its antennas, coordination vanished instantly. Meanwhile, every single American tank could talk to every other. During the Battle of Kasserine Pass, scattered U.S. tank crews, often from different units, managed to coordinate movements and artillery strikes across 50 miles of battlefield. German intelligence noted the clarity and range of American communications. One report simply said, "The Americans maintain contact where our radios produce only noise."
The difference came down to technology. German Fug-5 radios operated on amplitude modulation, 10 watts of power, range of 2 to 3 kilometers at best. The American SCR 508, 25 watts of frequency-modulated power, stable and clear for 10 to 15 miles. German radios picked up every spark plug firing and track turning as noise. The SCR 508 filtered it all out. Even in Italy's mountains, where terrain killed most signals, FM radios thrived. American tanks could coordinate through ridgelines where German radios went silent.
June 6, 1944, D-Day. Sherman tanks rolled off landing craft and into chaos. Their SCR 508s kept them linked to each other and to naval artillery offshore. But there was a flaw. Tank radios
couldn't talk to infantry radios. The infantry used the SCR-300, operating on different frequencies. In Normandy's hedgerows, this gap was deadly. Infantry couldn't warn tanks about Panzerfaust ambushes. The fix came fast. Tank crews welded field telephones to their hulls, wired directly to the intercom. By Operation Cobra in July 1944, infantry could speak directly to tank crews. The result? A revolution in combined arms warfare. From July 25th to 30th, 1944, Major General Edward Brooks's 2nd Armored Division coordinated over 200 Sherman tanks through a unified radio network. German defenders from the elite Panzer Lehr Division faced an enemy that seemed to possess omniscient awareness. American tanks reacted instantly to threats miles away. Artillery arrived within minutes. German forces, once the masters of blitzkrieg, were now fighting blind. Panzer Lehr's few surviving radios were choked with interference. Most of their tanks had none at all. The irony was cruel. Germany had invented radio-based armored warfare, but by 1944, they'd lost the ability to fight it.
Heinz Guderian, the father of blitzkrieg, had written in 1937 that radio communication was essential to armored warfare. But by 1943, his army couldn't deliver it. Germany built about 5,700 medium tanks that year, but fewer than 2,000 working Fug-5 transceivers. Only command tanks got them. The rest went to battle deaf and mute. Meanwhile, America equipped every single one of its 49,324 Sherman tanks with an SCR-508. Motorola's factories in Chicago produced over 50,000 radio sets, each with thousands of precision parts, capacitors, resistors, and crystal oscillators built to survive heat, vibration, and shock. It was the triumph of industrial organization as much as engineering.
By 1944, German tanks like the Panther and Tiger outgunned the Sherman. But firepower couldn't overcome isolation. During the Battle of Aricourt in September 1944, U.S. 4th Armored Division faced multiple German panzer brigades. On paper, the Germans had every advantage. In reality, the Americans had information dominance. Every Sherman could report targets, share positions, and call artillery within minutes. German tanks, unable to coordinate, were picked off one by one. The result? 281 German tanks destroyed for 41 Shermans lost, a 7-to-1 ratio that defied the specs. By March 1945, communication superiority had become unstoppable. When American troops discovered the Ludendorff Bridge at Remagen intact, the news spread by radio within minutes. In 1 hour, the U.S. First Army reorganized its entire front to seize it. German responses, dependent on landlines, came too late. Their communications network, bombed and brittle, collapsed. In the Ruhr Pocket, 325,000 German troops were trapped, partly because they simply couldn't coordinate. Field Marshal Walter Model's final messages read, "No contact with adjacent units, coordination impossible." For American crews, radio wasn't just a tool. It was a psychological lifeline. Even when isolated, they were never alone. German tankers felt the opposite. They fought in silence, disconnected, often unaware of what was happening around them. Otto Carius, one of Germany's top tank aces, later admitted that limited communications cost them more than any enemy weapon. Post-war analysis made it official. U.S. Army Intelligence Report numbered 176 concluded, German tank communications lag 5 years behind American systems. The Soviet Union agreed.
After inspecting captured equipment, they modeled their own post-war radios on the American SCR-508, not the German Fug 5. By 1950, NATO tank design doctrine revolved around one core lesson: connection beats firepower. German Bundeswehr manuals even stated, "The defeat of superior German tanks by inferior American vehicles proves that information dominance outweighs platform superiority."
The SCR-508 made the Sherman more than a tank. It made it part of a network, a web of communication that linked every vehicle, every unit, every decision. It was the first example of what we now call network-centric warfare. That principle, connection equals survival, still defines modern combat. From the Gulf War to Ukraine, the side with superior communication networks dominates the battlefield.
In 1943, German commanders thought they were facing chaos. What they were really facing was order made invisible, a battlefield woven together by radio waves. Titel's supposed remark at Germany's surrender summed it up best. "We knew how to build better tanks. You knew how to make them work together." And that's how the invisible weapon, the 181-pound radio, won the war.